Hey everyone, and welcome to this explainer from the Foundry by Forge College. Huge, massive congratulations on wrapping up your capstone project. Seriously, successfully assembling, validating, and preparing that AI-enhanced environment, that is a huge milestone. You've built the engine, you ran the tests, and you've proven your code works locally. But now it's time to actually take it out of the garage. Think of this explainer as your official engineering blueprint for taking all that perfectly validated code and getting it running in a live, scalable cloud environment. Okay, let's dive right into this. We're going to keep it crisp and cover 5 key things today. 1. Welcome to Solana Cloud. 2. The core value proposition. 3. The runtime blueprint. 4. The deployment workflow. And 5. Core principles to remember.
All right, part 1, welcome to Solana Cloud.
Like I just mentioned, you've secured a major win with your local program. But look, a perfectly validated local program is kind of like having this pristine, high-performance engine just sitting right in the middle of your garage floor. It's an amazing piece of engineering for sure, but actually, scratch that, it's totally useless if it's not taking you anywhere yet, right? You need a chassis, and you need a highway. And that is exactly what Solana Cloud is. It's a managed runtime and deployment service. So what does that actually mean for us? Basically, it gives your compiled on-chain programs a highly reliable place to run sidecar logic, scheduled workers, and runtime-attached services. And the absolute best part? It does all of this without forcing you to re-architect your entire program for every single hosting environment you come across. It's a real game changer. Moving on to part 2, the core value proposition. Now, you might be wondering, why do we even need a managed runtime? Why not just spin up a local server, write a few cron jobs, and, hack the whole shebang together yourself? Well, self-hosting off-chain scripts without any real lifecycle controls is, honestly, it's a bit like taping a flashlight to a Roomba and just hoping it effectively guards your house at night. I mean, sure, it's moving around, it's technically doing something, but it is wildly unpredictable and pretty much impossible to audit. Solana Cloud entirely replaces that chaos. It formalizes your off-chain interactions into declarative bindings. So instead of these ad hoc scripts just hoping to catch live program state, you get these observable, stable contracts where you can actually reason about correctness and scale. Section 3, the runtime blueprint. So we know we need a formal contract, right? But what does that actually look like in code? It all centers around a file called Solana Cloud Config TS. This is literally your patent schematic for gluing the on-chain and off-chain pieces together. Now, what's really interesting here is that a runtime descriptor isn't just like metadata or a list of helpful suggestions. No way. It's a declarative TypeScript configuration that acts as the absolute, strict scope for permissions and routing. When you make that leap from local testing to the cloud, this descriptor becomes the operational law that tells the runtime exactly how to manage execution and monitoring. Let's open up that blueprint and look at the gears and cogs. These configuration fields map directly to the artifacts you just finished validating. First, you've got name, which is just a human-friendly handle so you don't go crazy reading your logs. Region dictates your physical or logical location, absolutely crucial for RPC latency. Then image, that's the container wrapping up your sidecar logic and node runtime. Programs is this array where you bind your on-chain program identifiers to specific roles, which really defines your trust boundaries. Hooks are for your lifecycle attachments. And finally, env holds your runtime variables like, say, the specific RPC endpoint you're fetching block data from. I actually want to pause on hooks for a quick second because they are incredibly powerful. A runtime hook is basically a temporal contract. It defines exactly when the runtime takes action relative to the chain's progress. Think of like an onslaught trigger for batch settlement. Hooks are what make your entire system reliably reactive. They completely eliminate the guesswork of figuring out when your off-chain logic should actually fire. To put that into perspective, let's talk about the number 100. A really fantastic starter exercise, and one we actually use all the time across various learning programs here at Forge College, is writing a minimal descriptor that binds a program ID to a hook, watches a specific account, and then runs a handler exactly every 100 slots. It's a super simple but highly effective way to practice translating those compiled program artifacts into the exact declarative bindings that Solana Cloud expects. All right, part 4, the deployment workflow. Now we're shifting gears from sketching out the blueprint to running the actual assembly line. How does our local code transform into a breathing crowd runtime? Well, it's a very chronological, step-by-step process. Step 1, package and verify your artifacts. This is huge because it prevents drift between what you tested locally and what you're actually deploying. Honestly, just doing simple length checks on base 58 encoded public keys right here will save you literally hours of debugging later. Step 2, declare your runtime descriptor to set up those routing rules we talked about. Step 3, assign permissions and clearly scope your key material. Step 4, schedule your hooks and attach observability so you can correlate your logs. And finally, Step 5, operate and iterate by deploying updates to your worker images or tweaking those hook intervals. And this brilliantly illustrates how every single integration task maps to a specific capability. If you're doing batch settlement or Oracle polling, you're going to use runtime hooks. Need account-driven, reactive workflows? That's exactly what program bindings are for. Looking for operational automation? You leverage managed keys for service-level signing. And, when things inevitably go sideways and you need to do some post-incident debugging, you rely on observability streams to correlate your runtime logs directly with on-chain events. It just completely takes the guesswork out of the architecture.
Finally, Section 5, Core Principles to Remember.
Treat this part as the bold, red safety warnings manual for operating your new machinery. This first quote, it's completely non-negotiable. Separation of authorities preserves safety. Look, delegating service-level signing to the runtime is perfectly fine for operational automation, but your critical program upgrade authority, that must remain strictly off-cloud. Keep it in a multi-sig or a highly secure offline signer. Never, ever put the keys to your entire kingdom inside a cloud sidecar. So the crucial point is really summarized in these 3 main takeaways. First up, declarative bindings aren't just suggestions. They become your hard, operational, auditable contracts. Second, separate your authorities to drastically reduce your blast radius if something goes wrong. And third, always map your local test artifacts directly to runtime capabilities. So programs map to watched accounts and hooks map to temporal behavior. Doing this makes your deployments entirely predictable and, more importantly, repeatable.
I'm going to leave you with this question to chew on. Is your on-chain program actually ready to be securely wired into a managed cloud runtime? Take a minute to really think about your account schemas and your transaction patterns. In our next explainer, we're going to dive deep into components and roles, where we'll unpack everything we just talked about so you can properly assign responsibilities between your on-chain and off-chain teams. Until then, be sure to head over to forge.college to explore more Web3 resources, deep dives, and expert insights. Thanks for hanging out, and I'll see you in the next one.